Hi scientists! We have made it to step 2 of the scientific method. We already learned how to make testable questions, and we already recall that a testable question has to have a variable that you change on purpose, and it also has to have a variable that you observe or measure to see if it was affected by the change that you made. So let's think back to the testable question that we came up with yesterday, and we're going to write it here. Since we are working on this pendulum project throughout this whole unit, I'm going to use this question for my example. You'll use your own question. We ended up asking, will changing the length of the pendulum affect the number of cycles the pendulum completes in 15 seconds? Will a short pendulum complete the same amount of cycles as a long pendulum? That is our question. This can be tested by actually changing the length of the pendulum and counting the cycles. This is something that we can change and something that we can observe. So we are going to circle the variable that you change. For us, we are changing the length of the pendulum. So that is the piece that we're changing, the length of the pendulum. And then we're going to underline the thing that we're going to be observing or measuring. And that is going to be the number of cycles that the pendulum can complete in 15 seconds. So I'm just going to underline that. Perfect. Now doing that circling and underlining correctly is really going to help us later when we finish writing our hypothesis. Okay, next, in my own words, I know that one of the skills that scientists use is making predictions. So I'm just going to make a prediction about what I think, just when I think about it really quickly, what do I think is going to happen if I change the length of the pendulum? We don't need to use any special format here. We're just going to write our thoughts right from the beginning. I think that a shorter or longer string will probably make a difference on the number of cycles. That's just my guess. It doesn't matter to you as you are filling this out if your prediction does or does not match your hypothesis at the end. This is just a little bit of a brainstorm space. Now is where it gets good. Here is what makes a hypothesis a hypothesis. We must research, get some information about our question so that we can make an educated prediction, an educated hypothesis about what will happen when we do our experiment. Now, researching can be looking online. It can be thinking about what we've already done with this lab. It can be thinking about things we've experienced in our own lives. All of that goes into making a good hypothesis. So I did some research about the definition of a pendulum so I understand what I'm thinking about. I thought back to when I used to swing on swings with my friends at the park, and I remember we would try to go at the same time and we would try to stay lined up, but I know it was so hard. And now that I think back, maybe it was really challenging because the different swings were slightly different lengths, and maybe that did have an effect. I can also think to, when I'm doing this lab, I'm being very careful. I'm trying to isolate all my changes, make everything as precise as possible, probably because if I didn't and I was not so careful, the results might be affected, which makes me think changing the length of the pendulum will affect the number of cycles. And then finally, if I think about a pendulum and I think about the length of the string, if it's a very short pendulum, that makes me think it's a very short distance it has to travel. And if it's a very long pendulum, that's a very long distance it has to travel to get a whole cycle. Maybe a shorter distance doesn't take as much time, but maybe longer pendulums go faster and it balances out. I'm not totally sure. That's where I have to do an experiment. But based on my research and what I already know, I think I am pretty confident in my hypothesis that changing the length of the pendulum will affect the number of cycles. So if that's true, we're going to write our hypothesis in an if-then statement. If, and we're going to say the thing that we changes. So let's think back to what we circled from our question. If the length of the pendulum changes. So I'm going to say if I change the length of the pendulum, then the thing that I underlined will or will not be affected. The thing that I underlined is that thing that I'm going to measure, the number of cycles the pendulum completes in 15 seconds. So if I change the length of the pendulum, then the number of cycles the pendulum completes in 15 seconds will be affected. I could have said will not be affected, but my research makes me believe that it will change the number of cycles the pendulum completes. So this is my hypothesis in an if-then statement. It started with my testable question. It was informed by research, and now I have written it in an if-then statement. Now I can begin the next part of the scientific method when I actually get to test this, but you can't start testing at all until you know what you're looking for. Thanks.